Good graphics are a fundamental part of pretty much any scientific presentation. We use them in the earth sciences for a number of reasons. We might use them to illustrate concepts such as the Moore circle, where we can explain the relationships between stresses and brittle failure and faulting. Or we might use them to illustrate model results such as these outputs from the Mackenzie model, which relates subsidence through geological time for different stretching factors. Or we might cross-plot data, in this case fault length against the maximum displacement of a fault, to establish what the data look like and to maybe spot trends in the data. Or we can look at how ideas evolve. In this case, this tracks how ideas of different folding and fault relationships have evolved over the last 35-40 years or so. All of these are different types of graphical illustration. And we use them to reinforce the message that we're giving in our presentation. These will vary depending on what the objective of the presentation is. But the graphics we use and the ways in which we use them impact on how our credibility as a scientist and a presenter is viewed. So here we're going to be looking at how we can synchronize graphics with our oral presentation. How do the words and the image reinforce one another? And we'll use two examples of graphics which you can see on the screen at the moment. We'll take these in turn. So let's look at our first example, which is concerned with ideas of how basalt are formed. Basalt comes from mantle melting, and the crystallization products of these melts, the solid rocks, basalt, gabbros and so forth, are of course the components of oceanic crust. Well, the ideas hark back to the work of Dan Mackenzie and Mike Bickle in the 1980s, and their work is one of the most fundamental parts of modern plate tectonics. And their diagram, shown here from their paper, will appear in many basic textbooks on plate tectonics. So this is the diagram from the paper, and the temptation, of course, is to simply cut and paste this into a PowerPoint presentation when giving a talk. But this suffers from a number of basic disadvantages. It's monochrome, and is also very cluttered. So while when you read the paper you can spend the time decluttering it and decoding the diagram, in a talk the audience has less chance to do this. So of course you can redraft it in colour, which makes the original diagram far more accessible. So we've picked out a number of features in here which enhance the original published version. So the temptation now is to use this in a simple presentation. Let's imagine the audience reaction, and many will be happy, but others may react like this. And that reaction is to a large extent understandable. It's a complicated diagram. How do we provide the commentary for it? Let's see how complicated it is first of all. Their axes, in this case temperature and pressure or depth. Their relationships shown on the graph, in this case melt proportions or melt fractions generated through the melting process. Their labels on two important surfaces on here, the solidus and liquidus. Their explanations as to what they mean. Their pathways that rocks take through this diagram. And then of course there's the credit to the diagram itself, Mackenzie and Bickle 1988. So there's an awful lot to get out of this diagram. People sitting in the audience hoping to get something out of the ideas of how basalt is formed by partial melting of the mantle. Really, we need to take the audience through this story gradually, step by step, revealing the understanding that was developed by Dan Mackenzie and Mike Bickle, ending up with the diagram showing those relationships. In other words, we need to relate the reveal of the diagram to the narrative structure of the talk. And that's something we're going to explore together now. In order to do this, we need to design our diagrams appropriately. Now, I build my diagrams in Adobe Illustrator, but the functionality that I'll show you here is common to pretty much any reasonable graphics package. So here's a photograph of my laptop with that diagram sat there in Illustrator, and you can see the really critical part of this is not the diagram itself, it's that box on the right, which is the layer structure I've used to build the diagram. And you can see there are many layers in here, from the original diagram, which is not exposed, through a frame, and then various components of the diagram that we'll use to build up the story. So the critical thing when designing a diagram is to use layers, and then we can select individual layers for export. In other words, we can start off with just the axes of temperature versus pressure or depth. But beware the problem of jumping images. So in building up to that story through there, the images jumped around on the screen. That's a huge distraction. It may distract from listening to the words. And the way to avoid that and ensure that images register one on top of the other, a fundamental part of any type of animation, is to use a white box that is invisible but serves to restrict the image as you export it to within a defined area. Therefore, every exported image is an identical size. When they go into PowerPoint then, each image will sit one on top of the other from slide to slide. Like this. So we can tell our story with temperature plotted against pressure and depth. We can put on the solidus and the liquidus, which shows where you have 100% solid or 100% liquid, and a domain in between, which is a mixture of both solid and liquid in these proportions. So rocks passing through these domains will cross the solidus at different places and intersect the Earth's surface, having generated different proportions of melt. Those behaviours depend on the potential temperature of the mantle. So all those images registered one on top of the other as we told our story. There were no distractions extraneous to the narration. It's a relatively complicated story, so it's important that these distractions don't occur, or at least to minimise them. So, the recommendation is to register image is to use a white box, put it in its own layer, lock it out with a padlock, which you have in Illustrator and other packages, so that it's always there, and make sure there's no other objects that appear outside that box in any of the layers. Do that and your images will register one on top of the other. Okay, so now let's explore this using another example of a graphics which was developed to tell the story of this part of the Himalayas in Nanga Parbat, specifically the exhumation of migmatites that now are found at outcrop in this area. This exhumation process is tracked by cooling ages. And the story relates to this diagram. Well, the diagram was published in a review paper in 2020, but the work dates all the way back to the 1980s. So the temptation is to use this diagram directly into a talk. But there's a lot of clutter here that's extraneous to what we're trying to talk about. So let's clear it away and make the diagram bigger. That's better. So now let me tell the story of these data. So what we're looking at here is a profile constructed west-northwest, east-southeast that plots distance against the age of the rocks, and that age is a cooling age that tracks how the rocks have become exhumed over time. And if you look in the middle part of the diagram in here, you can see the rocks reach the surface in a very young age. Well, I'm using the plot here. All that story has been lost. Because if you're interested in this story, you'll be exploring the diagram on your own. Your eyes will be looking at the graph, looking at how the data are plotted on it, how much data there might be, how good those lines I've drawn on the diagram might be. And all that activity competes with the oral narration I'm giving explaining the diagram. And the upshot is the audience is probably getting neither message. So how can we do better? Well, the answer is we should synchronise our words and the way in which the image is displayed, so that the audience gets both the image and the words together. So let's have a go. So we're going to look at data collected on a west-northwest, east-southeast profile. And across this profile is the Nanga Parbat Haramosh Massif, HPHM. We're going to plot on this profile the cooling ages of rocks from 20 million years ago up to the present day. These data were originally collected by Peter Zeitler and others in the early 1980s and reinterpreted more recently. So let's start off by plotting the data for zircons. Zircons record the time that the rocks last saw a temperature of about 200 degrees centigrade. So how can we interpret these data? Well, let's look to the margins first of all. And the ages on the margins are older than 15 million years. So those rocks cooled through 200 degrees centigrade more than 15 million years ago. And now they're at the Earth's surface, so that's slow cooling. In contrast, in the massif itself, the rocks cooled through 200 degrees centigrade only 2 or 3 million years ago. So their cooling, compared to the margins, is much faster. And here's the profile joined up. Slow cooling on the margins, faster in the massif. Well, let's see what happens now if we use cooling ages from another mineral, in this case apatite. Now, as we go across our profile, at a particular place along the profile, the apatite ages are all younger than their zircon equivalents. And that's because apatite records the time that the rocks last saw 120 degrees centigrade. So as these are cooling, of course, the rocks that have cooled from 200 go through 120 somewhat later to reach the temperature they are at the surface today. So there's the apatite profile. Let's just interpret all this. Again, we have slow cooling on the margins of the massif, fast cooling in the rocks that form the Nanga Parbat Haramosh Massif. So differential cooling, presumably differential exhumation across the region. And the fastest exhumation in the region is occurring across the Nanga Parbat Haramosh Massif. But actually we can say a little bit more than that, because those profiles are asymmetric. There's a steeper gradient on the western side of the Nanga Parbat Haramosh Massif. So if we want to find structures that may be accommodating this exhumation, maybe we should focus here on the western margin. So let's go now and have a look. Well, that was the story of the fission track ages of the cooling history for the massif, and it assumed that people knew what fission track ages meant before we told it, which might have been covered in an earlier part of the talk or in an earlier lecture. The story, to get us through to this final diagram, took 15 steps. Think of that as 15 sentences. So each slide change represented a sentence with a new idea within it. We also used a couple of animated slide transitions, which were wipes, which ran from left to right when we exposed the line work that joined the data points up. This is quite a useful animation because it gives the indication of drawing an interpretation, in this case how the data link together. Otherwise, the transitions were simple. The story from this is use layers. So here we are back at my computer screen showing the graphic and the panel revealing the layers that define the structure of the graphic. So it's all about the layers. By combining different layers, we can gradually reveal the information through the explanation of the diagram. At times, we've had careful animations, we've revealed the labels, and critically, there's minimal text, so that the oral narration tell the story. The text words simply reinforce that message. They don't duplicate it. So a couple of examples of how we can synchronize our graphics to our oral narration. The message about the graphics on screen is to keep it clean, not too much clutter. If we have clutter, we're going to try and build it up gradually so that it's not intimidating to the audience on first inspection. The critical part, though, is to try and keep the reveal synchronized with the oral narration. Synchronize the words and the image. And this means that when designing the graphic, you need to understand the narrative structure you're going to use in the talk. And we'll use the layers and the exports of layers to build the presentation.